Hello, everyone. Today, what we're going to be doing, this is for Camden County College students. We're going to be reviewing some problem solving for section 6.1 and 6.2. This is on confidence intervals. And what we did on Tuesday was I gave you the basic principles of how to construct a confidence interval to estimate a population mean. 6.1 did this when we knew the population standard deviation, and 6.2, we constructed a confidence interval when we did not know the population standard deviation. So today I'm going to do a quick review of all of this, what we did last time. I will introduce you also to this concept called finding a minimum sample size. I'll show you how to do that. And then we'll do some examples from the textbook. Problem solving, but using our TI 83 and 84 calculator. Okay, so let's go ahead and share the screen, and we'll go to our textbook. And let's just go back. All right. So this page here is page 301 in the textbook, summarizes how to construct a confidence interval. Basically, we're going to take our sample mean, the one from the sample that we draw, and then we're going to add and subtract E here, which is called the margin of error. We talked about that last time. In 6.1, if we happen to know the population standard deviation, the margin of error is calculated this way. Z here is what's called a critical value, and sigma divided by the square root of n is called the standard error, or the sampling distribution of sample means. And then what we do is we take our margin of error. If we calculate it, we subtract it from the mean, sample mean, to get the left endpoint of the interval. We add the interval to the sample mean to get the right end of the interval. Okay. And then we did some examples last time, so you can review that in the video that I did on Tuesday. Now, one thing we did not cover in 6.1, which I wanted to do that today, is how to find what's called a minimum sample size. Now, why do we want to do that? Well, if somebody's doing research, let's say they want to do a survey, before they even survey people, they have to know how many people to survey. And so this has to be determined ahead of time. So how do we do it? How do we come up with that number? Well, one way of doing it is to take our formula for the margin of error and solve for the sample size n. Now, I can show you the algebra behind it, but probably not worth doing that. What we're really doing is just squaring both sides and cross multiplying, and we end up with this formula. N is equal to Z, critical value, times sigma divided by the margin of error E. Okay, so what do we need to find this so-called minimum sample size? We need to know our level of confidence. In other words, the researcher has to make a choice. They want to be 90% confident, 95% confident, 99% confident, and that will determine this critical value Z. The researcher also needs an estimate of the population standard deviation sigma. And then the researcher wants to also know ahead of time how wide the interval they want, and that's determined by the margin of error. The margin of error will give us that the size of the interval. Okay, so let's just actually do an example. All right, so let's say a researcher wants to estimate the mean number of hours spent on required athletic activities by all student athletes in the conference. How many student athletes must be included in the sample to be 95% confident that the sample mean is within 0.5 hours, or a half an hour of the population mean. Now, whenever you see the word within in one of these questions, that is the number right after that is the margin of error. That's E. All right, so you always look for that, unless they tell you margin of error is equal to You see the word within, that is the margin of error. All right, now, our level of confidence is 0.95 because we want to be 95% confident, so that's C. If you remember from last time, we did inverse normal, and we did a 95% confidence, and what we would do basically is we would draw our normal curve. The middle area is 0.95. That means what's left is 0.05 or 5%. Half of it goes to the left tail, half goes to the right tail. So the right tail is 0.025. So for the critical value, the area to the right is 2.5% or 0.025. And therefore, if you do inverse normal, the area to the left of the critical value is going to be 1 minus 0.025. And to find the z, the mean is 0, standard deviation 1. And we end up with 1.96. That's the one that's most commonly used, a critical value, because of the 95% confidence. All right, now, I think if you look at example 1, go back into the text, it mentions that an estimate for the population standard deviation is 2.3. And actually, if you look at example 2, it tells you that. Margin of error, of course, is 0.5 because that's what they tell you in the problem with the word within. So you just take these numbers and plug them into this formula. For Z critical value, you replace that with 1.96. For sigma, you replace that with 2.3. And for E, you replace that with 0.5. So you find that ratio and then square it, you get 81.29. Now, this is the number of student athletes. Well, we can't have 0.29 of an athlete. So what you always do is, no matter what the decimal is here, you round up to the next whole number. In this case, 82. So there are 80. So the researcher, if they're going to do this research, they want to be 95% confident for the confidence interval that they're going to end up having. And if they want the margin of error to be 0.5, then they have to have at least 82 people in the survey. They want more, that's great, but they should never have below 82 people in the survey. All right, so the interpretation is the researcher already has 40 student athletes. Now, where did the 40 come from? Well, if you look back at example 1, that's how many were done in the original sample. So if you want to meet all these requirements, the researcher should have had 82 in the sample, not 40. So they should have had an additional 42 people in the survey. All right, anyway, that's that. All right, so that's how to do a minimum sample size when you're going to be doing research to estimate a population mean. That's how you do it. Now, what we're going to do next is go into 6.2 and review what we learned last time. First of all, we learned again about the t-distribution. Remember, the t-distribution is the distribution that looks like a standard normal, but it has special properties. The mean is 0, just like the standard normal, but the standard deviation is larger than 1 right here, point number 5. And instead of using the mean and standard deviation as the parameters of this probability distribution T, we use what's called degrees of freedom. In this particular case, degrees of freedom is the sample size minus 1. So whatever the sample size is in the problem, the degrees of freedom is 1 less than that number. Okay. Now, why do we want to use the t-distribution? The reason we want to use the t-distribution is if we did not know the population standard deviation. If you remember in section 6.1, just a couple minutes ago, when we looked at the margin of error, we had z times sigma divided by the square root of n as the margin of error. But if sigma is unknown, if the population standard deviation is unknown, we have to estimate it. And how do we estimate it? With a sample standard deviation. In other words, the sample that we choose, that we've selected, the standard deviation of those people, all right, in the sample S, that's what we use to replace sigma, the unknown population standard deviation. And when we do that, we can no longer use the Z critical value. We must use a T critical value. Okay, so let's just make this a little bit bigger here if I can. All right, there we go. All right, so the steps are exactly the same as before. All right, calculate our margin of error, but the margin of error is a little bit different than 6.1. Use this instead of the one in 6.1. But we do the same thing to create our confidence interval. Once we calculate our margin of error, we subtract it from the sample mean to get the left endpoint of the interval, add it to the sample mean to get the right endpoint of the interval, and we have our confidence interval. All right. Now, the only thing that's different is to get the T critical value in this case here. And what do we use to find the T critical value? We use inverse T. Now, for those of you with the TI-83 calculator, hopefully you had brought it in on the days that I updated your calculator and put a little program in there called inverse T. So when we get to the calculator, I'll show what button that you push, and hopefully you have that program in there. If you don't, that means you weren't in class very often, because I did do it for several of you, and I think you probably all have it, but if you didn't, it's probably because you were missing class quite often. All right, anyway. And by the way, if you don't have that program and you have an 83 calculator, you should send me an email, and I will have to show you another way around this. There's another method that's a little more complicated, but I can show you how to get around this to find the T critical value. So you'll need to send me an email if you don't have an updated, have that program on your 83 calculator. All right, anyway. So let's look at this problem here. You randomly select 16 coffee shops and measure the temperature of this coffee sold at each of the coffee shops. This is, I think we might have done this last time, but I'll go over it again. The sample mean temperature is 162 degrees Fahrenheit with a sample standard deviation of 10 degrees Fahrenheit. Notice that they say the standard deviations from a sample. They don't mention anything about a population standard deviation. Construct a 95% confidence interval for that estimates the population mean temperature. All right. Assume the temperatures are normally distributed. Why did we have to say that? It's because the sample size is below 30. So the only way you can do this whole process, this whole construction of a confidence interval, is number one, if the population is normally distributed, then any sample size will do. But if we say nothing about the population, that it's normal, then the sample size has to be at least 30. Well, in this case, we do say that the temperatures are normally distributed. So since the population of temperatures is normally distributed, the sampling distribution of temperatures is also normally distributed. And it doesn't matter that the sample size is 30. Okay, it is explained in here. All right, once again, since sigma is unknown, it's not mentioned in the problem, but we do have the sample standard deviation mentioned. We're going to be using 6.2 formula, section 6.2 formula for calculating the margin of error. So we're going to use a T critical value, multiply that by S, the sample standard deviation, divided by the square root of the sample size. Now, how do we find the T critical value? Well, it's a 95% confidence interval, and N is equal to 16. So let's go to our calculator and determine what T is. In this case here, T critical value. Now, for those of you who I have updated your calculators, your 83 calculators, you're going to find inverse T right here. I don't have it on this particular calculator, this one that's from the Texas Instruments. This is not my calculator, this is theirs, so it doesn't have that program in there, but you should have it in there if I had updated your calculator. For everyone else who has an 84 calculator, you just hit second VARS, and to find the critical value, go down to inverse T, hit enter. Now it's a 95% confidence interval. That means the middle, if you draw a T curve, the middle 95%, the 95% confidence is the middle 95% of the curve, at least 5% left, half of it on the left, that's 2.5% on the left, half of it on the right, that's 2.5% on the right. So find the T critical value, the positive critical value. It's the one on the right. The area to the right is 0.025. That means the area to the left is 1 minus 0.025. So that's what it looks like here. Now the degrees of freedom. Now the sample size is 16. The degrees of freedom is 1 minus the sample size, so it should be 15. Scroll down, hit enter. And it's 2.1314 if you're going to round it to 4 decimal places. That's how you find the critical value. And if you go back to the text, notice that they have 2.131. They rounded it to 3 decimal places. That's our critical value. They multiplied it by 10, the sample standard deviation, this number here, divided by square root of 16. 16 is the sample size. And they get approximately 5.3 as the margin of error. Okay. And then they took the sample mean, which is 162. They subtracted 5.3 on the left, you get 156.7. And on the right, they added the 5.3 margin of error to the mean of 162 to get 167.3 on the right. So this is the 95% confidence interval. The way to interpret this is to say that with 95% confidence, you can say that the population mean temperature of coffee sold is between 156.7 degrees Fahrenheit and 167.3 degrees Fahrenheit. In other words, we are 95% confident that the true population mean is between these two numbers. All right, that's it. All right, so that's how you find constructed confidence interval. Now, sometimes the mean and standard deviation are given in the problem, like this one here. There's another example. All right, you can look through it on your own. But sometimes data is given to you. You're given a problem with data. I don't know if there's one here. No, there's not one here. So what we're going to now do is do some examples from the book. I think that's the best way for you to learn how to construct confidence intervals. So we're going to go back to 6.1 okay, and go to the exercises at the end of the chapter. And the very first one that we're going to use is, or do, is on page 305. It's the ones that's numbers 5 through 8. All right, it's the ones down here. All right, so what are they asking you to do here? Now, in this particular case, they're asking you to find the critical value Z. Remember, we used that in 6.1 when we know the population standard deviation, and we use the critical value Z to calculate our margin of error. So let's just practice with this. Number 5, suppose the level of confidence is 0.80. 80. So what I'm going to do now is show you a handout for this. So what you can do when you know the level of confidence is 0.80 and you want to calculate your critical value, nice little drawing, a normal curve drawing might be useful. This is, of course, our Z critical curve, our standard normal curve, where the mean is 0. It's going to have this 8, and what's in the middle here is 80%. So we draw an 80% in the middle. Since 20% is left, half of it 10% goes to the left tail, 10% goes to the right tail. So this critical value, there's one over here. There's a negative critical value here. There's a positive one. This is the one we want to determine. This critical value has an area to the right of 0.10, or 10%. So obviously the area to the left is 1 minus that, which is 0.90. And how do we know it's 0.90? Because middle is 80%, and then the left tail is an additional 10%. Okay. So anyway, put this into our calculator. What do? We put an inverse norm. In parentheses, we put 1 minus 0.10 for the area to the left of this critical value. You could put 9.90 if you wanted to. The mean is 0, standard deviation 1, and we calculate it. We get this number here, 1.28155, 1567. That's our critical value. And if we round it to 4 decimal places, there's our answer, 1.2816. 1.2816. Number 6 of the question asks for a level of confidence of 0.85. Well, that just means the middle area now is 0.85. What's left is 0.15. Half of it to the left, 0.075. Half of it to the right, 0.075. So how do we find the critical value for that one? Well, inverse normal. In this case, since the area to the right of the critical value is 0.075, the area to the left is 1 minus 0.075. Again, the mean is 0, standard deviation of 1. And we get this answer, 1.4395, as the critical value. Level of confidence is now 0.75. Well, that means the middle area is 0.75 of our standard normal curve. That means 25% is left, or 0.25. Half of it to the left, 0.125. Half of it to the right, 0.125. For the critical value, it would be 1 minus 0.125 area to the left. 1 minus 0.125. Again, 0, 1 for the mean and standard deviation, and we get 1.1503 for critical value. Finally, for a 97% level of confidence, that's what they show in question 8. 90.97 is the area in the middle. What's left is 3%, 1.5% on the left, 1.5% on the right. We use 0.015 instead of the percentage. The area to the left of the critical value is 1 minus 0.015. And then we get our critical value is 2.1717, again, inverse normal. All right. Now, the next question is number 9 on page 305. Okay. This one right here, number 9. So it says use the numbers on values on the number line to find the sampling error. The sampling error is x bar minus mu. It's the point estimate, the sample mean minus the population mean, in that order. You put the sample mean first and the population mean second. It's x bar minus mu. So it's 3.8 minus 4.27. All right, and that's our answer. It's going to be negative 0.47. Now, it's not on your sheet, but if mu happened to be lower than x bar, then it would still be x bar minus mu. It'd be 26.43 minus 24.67, and that would be 1.76, positive 1.76 is your sampling error. Okay. So hopefully that is clear to you. All right, and again, I just did the one there. Now, problem 17 to 20 on the same page is sort of a matching problem. Let's take a look at it. Basically, this one here, these here. Basically, they're saying, all right, here are four confidence intervals for the very same sample data. In other words, it's the same mean. 57.2 is the mean of the sample, just one sample, but there are four different confidence intervals. Now, what would be different between the four? Well, certainly it has the same standard deviation, the same mean, right? The same sample size. The only thing that's different is the level of confidence, right? Now, here's the general rule. As the level of confidence gets bigger, the length of the confidence interval gets longer. Okay? In other words, it becomes wider, a wider interval. Now, how can we recognize? We look at four intervals here. How do we know which interval is the widest? Which one is the most narrow? Well, you just take a look at the left endpoints here. The left endpoints. All right. The the one that's the most narrow has the largest left endpoint and the smallest right endpoint. All right. If we subtract these two numbers here, we get 3.2. 58.8 minus 55.6 is 3.2. You subtract these two numbers here, we get 3.4. If we subtract, let's see, subtract these two here, we get 4.7, even wider. And this, if we subtract these two here, we get 4.6. So certainly, that's how you determine the width of each interval. Just subtract the endpoints. All right. So which one has the smallest? Which one is the most narrow of the intervals? It's this one right here, 55.6 to 58.8. And this is the most narrow, the next most narrow one. And this one here is the next most narrow one, and this is the widest one. So as the level of confidence increases, the interval becomes wider. So since this is the smallest level of confidence, it must be the most narrow of the four. And which one did we choose? C. So this one C here, this interval C, corresponds to the level of confidence, 88% level of confidence. What's the next most narrow one? This one here. This is one that's a little wider. That's the 90% confidence, level of confidence. All right. What's the next most narrow one? It's B. That's the 95% level of confidence. And then finally, C is the widest one. It's A, this one right here. Okay. That's how you answer that question. C, D, B, A. Okay. Now we're going to go to page 306 in our textbook. And we're going to answer question number 33. We're actually going to do a word problem with confidence intervals. Actually, this one is actually asking for the margin of error, number 33. So strictly a margin of error question. Now, what they're giving you here is the actual confidence interval. In other words, they're not asking you to construct it. Right? They're asking you to find the margin of error, and they're asking you to also find the sample mean. In other words, they're asking you to work backwards. Here's the level, here's the confidence interval, left endpoint, right endpoint. Left endpoint's 26.2, right endpoint's 30.1. How do you figure out the margin of error and the sample mean? All right, so let's take a look at the solution. Well, if you think about how to construct a confidence interval, what do we do? The left endpoint is we take our sample mean and subtract the margin of error. And then to find the right endpoint, we take our sample mean and add the margin of error. What that means is that the width of the interval, the length of the interval, has to be 2 times the margin of error. 2 times the margin of error. Okay. So How do we find the margin of error? Well, actually, I don't know. Did we do it here? Yes, we did. So we subtract the two endpoints. That gives us the length of the confidence interval. And since that's twice the margin of error, we divide it by 2 to get the actual margin of error, which is 1.95. So if you're given the interval and you're being asked to find the margin of error, you just subtract the two endpoints, the right endpoint minus the left endpoint, divided by 2, and you get your margin of error. Now, to find the mean, you have a couple different choices. You could simply find the average of the two endpoints. In other words, add the two endpoints and divide by 2. That gives you your sample mean. Or if you already know the margin of error, which we do, 1.95, you simply add that to the left endpoint and get the sample mean. There's two ways of getting that. All right. Now let's look at problem number 35. All right, and they're asking here to construct confidence interval. Now in the problem, they're saying construct a 90% confidence interval and construct a 95% confidence interval. Well, I'm just going to construct the 90% one just to show you how it works. So it's number 35, gold prices. It says from a random sample of 48 business days, notice it's not people now, the sample is of business days from January 4th, 2010 through February 24th, 2017. Obviously, there's thousands of these business days between those two dates, okay, over 2,000 business days. They're taking a random sample of 48 of those business days. And they're looking at gold prices, US gold prices. All right, so in the random sample, the sample mean of gold prices for those 48 business days is $1,368.48. They're saying assume that the population standard deviation is $202.60. So this mean here is X bar for the 48 days, and sigma, the population standard deviation, is being estimated to be $202.60. So let's take a look at how to solve that. Fine. We're going to do a 90% confidence interval in this case here. So I wrote down the sample size of 48. X bar is $1,368.48. Sigma, the population, the estimate of the population standard deviation is $202.60. The critical value is Z90. How do we find Z90? Well, again, inverse normal. And remember, if 90% is in the middle, that's 5% on the left tail, 5% is on the right tail. So the area to the left of the critical value is 1 minus 0.05. Inverse normal, and our Z critical value is 1.645. So margin of error is Z times sigma divided by the square root of n. Here's our critical value, 1.645. Our estimate of the population standard deviation is 202.6. And it's divided by the square root of the sample size, which is square root of 48. And our margin of error turns out to be 48.10. I guess $48.10. And when we subtract it from X bar and when we add it to X bar, we get these endpoints here. So we take 1368.48, subtract 48.10 to get our left endpoint, 36.48, and add 48.10 to get our right endpoint. And this becomes our 90% confidence interval. Okay. Now, I just wanted to mention that in the book, there's two ways of displaying a confidence interval. You'll see this also on your final exam. Your confidence interval is displayed this way with, say, mu in the middle, and it'll have these less than symbols here. And in the book, it has it as parentheses with a comma in between. So the left number is your left endpoint, the right number is your right endpoint. So you could see confidence intervals displayed in both these different ways. All right, let's look at page 307, number 45. So we go to the next page. All right. So this is another confidence interval problem. Now, the reason I wanted to show you this is sometimes you're not given the mean, the sample mean. You have to actually figure it out. So if they give you data like this, and they're asking you to come up to do a confidence interval, you have to enter it into your calculator as a list. And then go to one variable statistics and find X bar, the sample mean. Now, they're telling you in this case, from past studies, we're using sigma as 6.5 minutes. Now, what is this particular study? It says a group of researchers estimates the mean length of time the average US adult spends watching television using DVRs and other forms of time-shifted television. All right, so this is in minutes. All right, so 30 US adults are selected randomly, and these are the times for each of the 30 adults state that is the time they spend watching TV using DVRs. All right, so these are in minutes. So what do? You enter it into your calculator. So let's go. I think I've already done that. Go to stat, hit enter, and that would be L4. L4 starts at 29, goes to 12. Let's just double check that's the right one. Yeah. So I'll just enter all 30 of these into L4. So ignore what's in L1, L2, L3. Ignore L5 for now. L4 has those 30 numbers. So to find the mean, we do hit stat. Sorry about that. We scroll over the calc, hit enter. We go to one variable statistics. We're going to type in L4 because that's where my numbers are. And we scroll down, hit enter. And so our mean of that sample of 30 times is 22.867 if we round it to 3 decimal places. Now, since they're giving us the population standard deviation in the problem, we will not use S, the sample standard deviation. It's always preferable to use an estimate of the population standard deviation. So if they give it to us, we definitely use it. Okay? 22.867 is our mean. Okay? This is where I have it here. Sigma is 6.5. That's what they gave us. And we're going to construct a 99% confidence interval in this case here. I think they give us a choice between two types, 90 and 99%. We're going to do a 99% confidence interval for this. Okay, let's get back to the solutions. All right, so here's our standard deviation. We got that from one variable statistic, excuse me, our sample mean that we got from our one variable statistics. Here's our estimate of the population standard deviation. Here's our level of confidence, 0.99. We need to find the critical value first, so we do inverse normal. Now, if the middle of the normal curve is 99%, that means 1% is left. A half of 1% is on the left, a half of 1% is on the right. So the critical value, the area to the left of it is going to be 1 minus 0.005. 0.005 is 0.5%. We get 2.576 is our critical value, rounded. Plug it into our formula for the margin of error. 2.576 replaces the z. 6.5 is our estimated population standard deviation. Our sample size is 30, so we divide it by the square root of 30. And our margin of error is 3.057. Take that 3.057, subtract it from the mean. We get our left endpoint of 19.810. We take the sample, if we take our margin of error and add it to the mean, we get 25.924, and this is our 99% confidence interval. Now, in the solutions here, I use CI. I hope you all realize that means confidence interval. All right. Next thing is a minimum sample size problem. It's page 307, number 49, part A. Let's go back. Same number, 49, part A. All right. Cholesterol contents of cheese. It says a cheese processing company wants to estimate the mean cholesterol content of all 1 ounce servings of a type of cheese. The estimate must be within 0.75 milligrams of the population mean. All right, here's the word within. So if they give you the word within, that number there is the margin of error, 0.75. That's E. Determine the minimum sample size required to construct a 95% confidence interval. All right, that means C is going to be 0.95. That's a level of confidence. Assume the population standard deviation is 3.1. It's important to do a minimum sample size problem that they give you an estimate of the population standard deviation. It's 3.1. That's sigma. All right, let's go to the solutions. All right, once again, here's our margin of error formula. If you solve for n, you get this as the formula for finding the minimum sample size. You simply plug in the numbers that we saw. So if it's a 95% confidence interval, we know from previous examples that 1.96 is our critical value. 3.1 is our estimate of our standard deviation. And it said, didn't say margin of error in the problem, but it did say within 0.75. That is our margin of error, 0.75. We then square that with this, all of this inside the brackets. We square it, we get 65.63. Once again, we round up to the next whole number. It's 66, and that's our minimum sample size. All right, now let's do some problems in 6.2. And we're going to look on page 315. All right, let's go back to the textbook. We're going to go to 6.2. And here we are, page 315. And we're going to look at examples. Which examples we're going to look at? Examples 1 through 4. And what are we finding in this case here? Well, we're practicing how to find T critical values. Why do we need T critical values? Because to construct our margin of error for confidence intervals. When sigma, the population standard deviation, is unknown, we need to use T critical values instead of Z critical values. All right. So they give us the numbers here. They give us the answers here. So it's typically we use inverse T. For those of you with the 84 calculators, you use the program that I programmed into the 83 calculators. Again, if you have an 83 calculator and I did not program, so let me just show you once again. You have an 83 calculator, this button in the middle here, this program button, is where I would have programmed the inverse T. Now, if you don't have that and you have an 83 calculator and you're missing inverse T in this list here, then again, you'll need to email me and I will give you a workaround for finding the inverse T. All right, so please email me. If you don't, and you're taking these tests, like the test number 3 and the final exam, you're going to have an issue. You're going to have a problem finding the inverse of T. All right, but you need to email me and I'll give you that workaround. All right, anyway, so let's go back to the, so these 4 is what we're answering in the book. Okay, so T90. So they give you the sample size, right? The sample size is n. To find the degrees of freedom, you subtract 1 from n, and that is the parameter that you put into inverse T. It's the second number that you put in for inverse T. What's the first number? It's the area to the left of the critical value. For a 90% confidence interval, the area to the left is 1 minus 0.05 or 0.95. A 95% confidence interval, the area to the left is 1 minus 0.025 or 0.975. For a 99% confidence interval, the area to the left is 1 minus 0.005 or 0.995. For a 98% confidence interval, the area to the left is going to be 1 minus 0.01 or 0.99. Now, what are the second numbers here? Well, problem number 1 says the sample size is 10, so our degrees of freedom is 9. For the second problem, degrees of freedom, the sample size is 12, degrees of freedom is 11. For problem 3, the sample size is 16, the degrees of freedom is 15. And for problem 4, sample size is 40, the degrees of freedom is 39. So you put these into your calculator, you get these as your critical values. And that's how you find critical values using inverse T. All right, so it's very important to know how to do that. Yeah. Question number 5 on the same page, let's go to that same page, is asking you to calculate the margin of error when they give you the C here, which is the level of confidence. They give you the sample standard deviation and the sample size. All right, so I'm just doing number 5 where the level of confidence is 0.95, the sample standard deviation is 5, and the sample size is 16. So how do you figure out the margin of error? It's the critical value times the standard error, which is S divided by the square root of N. All right. Now, if N is 16, that means the degrees of freedom is 15. You need to find the critical value for a 95% confidence interval. That means the area to the left is 1 minus 0.025. The degrees of freedom is 16 minus 1, which is 15. You find this number here, 2.1314, and so forth, is the critical value. Multiply that by the sample standard deviation of 5, divided by the square root of the sample size, which is 16, and you get 2.6643 as your margin of error. So that's an example of that. Let's look at number 17 on the same page. And they're actually doing an example here of a confidence interval. We're assuming, by the way, that the population, it says assume the population is normally distributed. Well, if you look at problem 17, it says a random sample of 8 people. Well, that's much less than 30. So the only way the sampling distribution is normal is if the population is normal, and it is. So we're good. All right, anyway, 35 says in a sample of 8 people, the mean commute time is 34.5 minutes, and the standard deviation is 7.2 minutes. All right, it does not say population standard deviation. It doesn't say sample standard deviation either. But if it doesn't say population standard deviation, assume it's a sample standard deviation. All right, just make that assumption. That's S, 7.2. So X bar is 35.5, S is 7.2, and N is 8. Let's look at the solution. Here are all the numbers. We're finding level of confidence 95, because that's, so we need a 95% confidence interval. All right. Now, how do we figure out our critical value? It's inverse T, it's 95%, 1 minus 0.025. The sample size is 8 in this case here. That means the degrees of freedom is 7. And we get 2.3646 is our critical value. We plug that in for critical value in our margin of error formula. S is given to you as 7.2. Sample size is 8, so it's divided by the square root of 8. And our margin of error is 6.0194. We round it to 4 decimal places. Okay. Our mean is 35.5. Okay. Now, by the way, I'm rounding this all to 1 decimal place, so it's going to be 6.0. So when I subtract 35.5 minus 6.0, in other words, I'm subtracting from the mean the margin of error. So 35.5 minus 6.0. That's what I get here on the left. I get 29.5. And on the right, the mean plus the margin of error, 35.5 plus 6, I get 41.5 as the right endpoint of the 95% confidence interval. So this is it right here. All right. Now the very last problem in for today, and this is our this is 6.2, number 31 on page 316. We're going to go over to page 316, and we'll scroll down, and we're going to get to number 31. Now, number 31, I wanted to show you this problem because it has data. It doesn't give you the sample mean at all. It gives you the data. So there are 32 numbers here. What are these numbers here? Annual earnings of 32 randomly selected MRI technologists. These are people who run those MRI machines, all right? Specially trained people who run those. And these are their salaries, I guess, throughout some area or country, whatever, I don't know. But they're randomly selected. Obviously, there are probably hundreds or even thousands of these people all over the country. So we're randomly selecting 32 of them and asking them how much do you earn in a year. So these are their salaries. I guess it must make you want to learn how to become one of these people because these salaries are pretty high. So what do? You enter these numbers into a list, into your calculator, and that's what I did earlier. If you go to Stat and enter, and under L5 are those the salaries, those 32 salaries, all listed in L5. So if I go to, if I hit second, if I hit Stat, scroll over to Calc, enter, I go to one variable statistics, and here I'm going to put L5. It's my list because that's where the numbers are, the dollar, those salaries are. I hit enter. And so our sample mean, the sample average of those 32 salaries is $68,757, and I'll round it to 94 cents. Now, the problem does not give you a population standard deviation at all. It doesn't give me an estimate. So you have to use the sample standard deviation in place of the population standard deviation. So the sample is S. You have to use S. Don't use sigma. Use S. And S is $15,834.18. So let's go back to the problem. What are they asking? Well, if you look up here, they're asking, what does the sample mean? Well, we just figured it out. $68,757.94. What is the sample standard deviation? $15,834.18. I write those down right here because we got that right out of one variable statistics. Now C is going to ask us for what? Let's look at part C. Part C is asking us to construct a 98% confidence interval for the population mean. Our level of confidence is 0.98. It's right here. N is 32. Degrees of freedom is 31. Now, because we don't know the population standard deviation, we must use this formula for a margin of error. Therefore, we have to find our critical value first. What's our critical value? Use inverse T. If it's a 98% confidence, that means the middle area under the T curve is 0.98. That means there's 2% left, 0.02 left, 0.01 on the left, 0.01 on the right. That means the area to the left of the critical value is 1 minus 0.01, which is 0.99. Degrees of freedom is 31. And we put that into our calculator, we get 2.542824.181. That's our critical value. We plug that into the formula for the margin of error right here. We take our number that came, our S, or sample standard deviation that came from one variable statistics. We plug it in for S right here. And we divide by the square root of N. There's 32 of those salaries. N is 32. And when we multiply and divide, we get $6,865.73 is our margin of error. Okay. And once again, our sample mean is $68,757.94. And the left end is that number minus the margin of error. The right end is that mean plus the margin of error. And we get this as our left end point. We get this number as our right end point. And the way to say this in English, we say we are 98% confident that the population mean salary for these technologists is between $61,892.21 and $75,622.67. All right. So once again, a confidence interval estimates a population parameter, in this case, the population mean. All right, so that is it. I'll stop sharing. All right, so that is it for today. And what we're going to do next Tuesday, is we're going to cover 6.3. And in 6.3, what we're going to be doing is we're going to be estimating a population, what we call a population proportion. We're going to talk more about that on Monday, or excuse me, on Tuesday next week. I'll create another video next Tuesday. And then next Thursday, we'll do, just like we did today, we'll do sample problems from 6.3. And I will post, of course, homework for that also. All right, that's it for today. And for those of you who are celebrating a holiday this weekend, have a happy holiday and stay safe and healthy. All right, we'll see you next Tuesday. And I will post this video. Obviously, if you see this video, you know it's posted. So, but anyway, in addition to this video, I will be posting the solutions to the problems that I went over today. All right. Again, have a good weekend and see you soon.